Welcome everyone to the ONS UNECE Machine Learning Group. It's great to see you all here. For those of you who don't know, our Machine Learning Group is an international community that facilitates research collaboration, knowledge exchange and skills building in machine learning for the official statistics community. The Coffee and Coding series is an interactive, informal session for helping statisticians and data scientists build core data science skills. And we have over 350 people signed up today. Great to see you all. So please introduce yourselves in the Teams chat. If I could just ask Hannah now if you could switch on the recording as well. And we will be ready to start. So just a few housekeeping notes before we get into the session itself. We will be recording today's Coffee and Coding session, and this will be available on our website after the event, along with the presentation slides. And this is a really interactive and formal session. We are really keen to hear your questions and comments. So please do post those throughout the session. We will be muting microphones and cameras apart from for the presenters during this session, so that because we just have a very large number of people on the call. So instead, we will be taking your questions and comments on Slido. So you can see the details for the Slido website up on the screen there. So if you go to slido.com and type in the code 3881745, then you can get to the polls and the question page that we'll be using in the session. And also we will be sending you all a feedback survey afterwards. We'd really like to hear how you found the session and if there's anything that we can improve for future ones. So in the ONS UNECE Machine Learning Group this year, we've been exploring the capabilities that statistical organisations need to have in place to implement machine learning programmes successfully. And one issue that has come up quite frequently is knowledge of how to use a version control system. And this has been raised as a really important requirement for working collaboratively and keeping track of changes in machine learning projects. So over the next 90 minutes, we'll be given an introduction to GitHub and Git from our colleagues at Statistics Canada. Our trainers today are Tabitha Williams and Brittny Vongdara from Statistics Canada. So we'd like to give them a very warm welcome and thank them for preparing this really great interactive and fun session. I know that they've prepared for us today. So welcome Tabitha and Brittny, and over to you.
Allison, thank you. Sorry, I just lost my voice again. Sorry about that. I'm Tabitha Williams, and I work at Statistics Canada. And as part of my work at Statistics Canada, I am on the UNECE HLG MOS working group for Work Package 2, and I realize that is a lot of acronyms and things. And essentially, I'm working with the UNECE high-level group on the modernization of statistics to create a course on how to use Git. My colleague Brittny Vongdara is here to help moderate with the chat, and she is also a Git and GitHub pro. If you hear screaming in the background, it is my cat. I apologize. He is upset. I don't know about life. So we've labeled this session Get Good. It's just a really, a little devil beast. Okay, it's just a really quick introduction to Git and GitHub. So we're not going to go too much into like actually using Git itself, in part because there's less interactivity with that. but we'll get to there. So for now, if you don't mind going to the Slido, we are going to do like a preconceived notions exercise. Some of you have already popped into the Slido and started that. For the rest of you, we'll take 2 minutes until 9:09. So if you haven't popped into the Slido and put in some words about what are just the first things you think of when you hear Git or GitHub or GitLab, drop those into the Slido. And then maybe if, oh, Inkyang has put the Slido link in the chat as well. And Hannah or Brittny, or I guess Hannah, if you want to share the poll.
Yes.
I stopped sharing very quickly.
Great, thank you.
Awesome. Cool. So we have a lot of people starting to use that. We're getting a lot of version control. That's great. That's great to hear. I mean, it's a good sign. You know what Git and GitHub fundamentally are for. Getting a lot of things like opaque and complicated. Yep, lots of collaboration. Love the unintuitive one. Sometimes Git can be very unintuitive. And lots of versioning. So those are all great things to think of when you think of Git. Hopefully for some of the things that are, you know, daunting or unintuitive or technical, maybe we can get rid of some of those assumptions today, and hopefully some of these things will change for you. Some of them might not, but we'll do our best to get there. Big fan of the person who put joy. GitHub also brings me joy, so I love that. We'll just give it a couple more seconds. There's a couple more people typing. And open source. Oh, I love that. Yeah, we're big on open source. Really like using GitHub and GitLab for that here at StatCan. And I mean, that's fundamentally what it's for. So, Hannah, I'm just going to go back to sharing the presentation, but thank you all for participating in that. Really appreciate it. Kind of gets everybody warmed up a bit. Just going to go back to our agenda for today. So we did an introduction, we did our preconceived notions. We're going to talk a little bit about what are GitHub and GitLab, or GitHub and Git. We will have a 10-minute break, and then we're going to do a little demo where I encourage you all to follow along. So hopefully you have a GitHub account. If not, maybe you want to create one during the break. It takes about 5 minutes, and it's pretty quick. And then we'll close out the session for today. Well, I won't, Hannah and Allison will. So a lot of you in the preconceived notions exercise understand why controlling or version controlling code matters, not just for NSOs, but for governmental organizations and non-governmental organizations. And a lot of you touched on these words. So the idea of reproducibility. So by being part of the organizations that we're a part of, we need to be able to produce our outputs more than once. So we need to create things that other people can reproduce. Having version controlled code is a really easy way to make sure that that happens. We also like it for the efficient and effective development of code. It is very efficient to put all of your code in one central place, as opposed to tracking down 18 different versions on your shared drive or in your email. Have done it, don't recommend it. I'm sure a lot of you have gone through the same thing. And then, of course, we want to be able to create standardization between and within organizations. So if all your code is up on GitHub or GitLab and it's version controlled, people who are undertaking very similar projects to you can use the same methods. So we know then that price indexes can all be calculated in the same way. We have all our methodologies, all our confidence interval calculations, our confidence measure calculations. And so we can standardize that within Statistics Canada or within an NSO or an NGO or just a governmental organization. But when we share it externally, it also means that we can create that standardization between organizations. So it means that by sharing our code externally, we can create kind of a standard between Statistics Canada and the Bureau of Labor Statistics, or between us and the UNECE. A lot of you will be measuring or reporting on sustainable development goals in your organization. That's a huge use case for using things like GitHub to share your code. How are you measuring these? Are we creating comparable data sets? And the same thing goes for when you're doing machine learning, right? It helps if you're going to do the same model on a bunch of different data sets between organizations. You want to be able to have some standardization before you can then go and go, oh, this isn't working for us, we'll experiment with something else. And the big reason is the final reason, and it's to easily disseminate changes and your updated versions of programs. So instead of sending out an email that has, a new version of the code, we know it's on GitHub. We know it's in one place. You can put your updates there. Depending on how things are set up, people who are watching your repository will get a notification, so they'll know a major change has been made. Or if they've done what's called a fork, and don't worry, we'll get into that, it can be set up that any repository who is forked from yours will get those updates as well. So we're going to talk a little bit about what Git is fundamentally. Most of you know what it is, but just in case, it's an open source version control system. So it's not paid, which is nice for most of our organizations. And it is open source so that we are working with a tool that is actually in the spirit of what we're trying to do. It's also an industry standard, which is very helpful. So there are lots of resources on it. As a program, it's one that's actually installed locally on your computer. And if you aren't familiar with Git, it's kind of like track changes in Microsoft Word or version history on like Google Docs. Now there is a GUI, so a graphical user interface, and there's also a command line that are installed with Git as its base program. We use a lot of the command line functionality at Statistics Canada, but you can absolutely use the GUI. There are other GUI interfaces that you can download. So on my personal machine at home, I use GitHub for Desktop, which is a very helpful way of working with Git. So we'll talk a little bit about what GitHub/GitLab are. I know we got some questions during the registration about GitHub versus GitLab, and we'll get into that too. So whereas Git was the thing that was installed locally on your machine, GitHub and GitLab are just browser-based, so they're web-based services. And they're what allow for the collaborative coding and the dissemination of code. You can install instances of GitHub and GitLab on an internal server. Lots of statistical agencies do this. We've done this. I believe the OECD also has done this. And that's if you're concerned about privacy or security. But most people, by and large, use GitHub just open on the web. Both platforms have project management features. So if you're familiar with things like Kanban boards, there are Kanban boards on them. You can make essentially to-do lists where those lists are assigned to people. You can manage things like sprints. So a lot of you on development teams will be familiar with sprints. And those are all things that you can do to manage them. And then there are also some project management features to kind of protect against errors in coding. So you can control permissions to make sure that your intern doesn't put code on the production. So without it being reviewed first by a senior developer, which is a super important feature and one that we use a lot. And with that, like, yes, you can control who is able to change certain things, but you can also control who can see different things. So if you are worried about security or privacy, you can make a repository private. If you really are, on that working out in the open, you can make it public. So we try and make things as public as possible, but it's not always possible for us. So talked about Git, we talked about GitHub. Git actually connects to GitHub. So we make our changes locally, so obviously, right? You don't want to code everything in the browser. It will take 100 years. It's much more efficient to code in your preferred IDE of choice, run all your tests, make sure your model is working as you intended to. So we save all those changes using Git, and then Git uploads them to GitHub when we're ready to share them with everybody else. This also means, so we can have multiple people connecting to the same GitHub project. So if on your team, multiple people have Git installed, they can connect it to the same GitHub project, provided they have the permissions. So it's really helpful because then everybody can work locally and you can all upload all your changes into the same place. And your colleagues can pull down their changes as they're working to get any updates that you've made to the code. So when we take updates that we want to put onto GitHub, it's called a push. Because we're pushing up a change. And when we want to download any new changes to the code before we start working, we're going to do what's called a pull. So we've got a little graphic to vaguely show what it looks like. It's a little bit more complicated. There's security protocols and the whole bit. How you connect Git and GitHub will largely depend on your organization's infrastructure. So that's part of the reason we're not going to go into it today. There's a particular way that we at Statistics Canada have to connect to it, and it might be different than how your organization has to connect to it. So talk to your IT people about what ports they have open, what security protocols you guys have, and then that will give you a method that you can very easily look up and see how to connect with. So that is our very, very brief introduction to fundamentally what is GitHub and what is Git. We did take some of your questions on the registration. So here are some common questions that we got. We got a lot of questions about using GitHub with RStudio and VS Code. A lot of IDEs have GitHub integration or Git integration. They will have a tutorial. Both RStudio and VS Code in particular have tutorials on how to connect a Git or GitHub project. It's pretty easy to do. With VS Code, you do need an extension, so just make sure that is installed. We got a lot of questions about using GitHub versus GitLab. Y'all are machine learning people, so the big difference for you will be the continuous integration. So when you make a change, it will run code and, you know, run your model, create your outputs. That will all be done in GitHub or GitLab. With GitLab, it's called CI or CD CI. That is already built in. In GitHub, that is not built in. It has the functionality. You just have to install whichever service you like best. So that's the big difference. GitLab is more geared for enterprises, though. However, GitHub pretty much has all the same project management features. We got a lot of questions about data privacy. The big way to kind of keep data private, keep it secure, is to use what's called a git ignore file. This is a file that will tell Git to ignore things. It's very aptly named. Kind of what makes Git nice. Essentially, you just scream Git and another verb or noun, and Git does things. But a git ignore file you can use to ignore all data files, so that data files are never uploaded to GitLab or pushed up to GitLab. And you can also use git ignore files to ignore very specific files or entire folders. So there are lots of tutorials on how to do that. If you're familiar with regex, it follows regex patterning. And we got lots and lots of questions about, oh, sorry, and also I forgot the git status. If you're using the command line, the command git status will tell you what you staged, so what you are about to upload to GitHub, and what you aren't about to upload to GitHub. Using that command frequently and often is one of the best ways to see if you're about to upload something that shouldn't go up. If you're using a GUI, you will see in green usually what you are about to upload to GitHub. So always take a look at that. Like, it's usually when you've integrated into an IDE, so RStudio or VS Code, you'll see on, usually it's a side panel, and you'll see your Git extension with a window, and it will tell you in green what files are about to go up. Just take a quick look over there before you actually hit push or upload, depending on what the commands are on the IDE. And yeah, so one of the big ones was we got lots of questions about avoiding merge conflicts or how to collaborate. So a merge conflict happens when two people have worked on the same file at the same time, and Git or GitHub can't reconcile that. If any of you have worked on a Microsoft Word file off a shared drive, you'll see sometimes it will freak out if somebody else is working on it at the same time. That's essentially what's happening when you have what's called a merge conflict. One way to solve that is by pulling frequently. So downloading any updates from your repository as you're working to merge them into what you're doing. Another way is by using what are called branches. So talked a little bit about keeping the intern off of production. Branches are essentially copies of the project that exist only within the project. So you have a source of truth that you then create a parallel copy on and work on. So usually you have a production branch, and then you have development branches based on your different features. Not working on the production branch is the best way to make sure that you're not going to have a merge conflict. And so using the branches, you push up your updates and then you merge them over. We'll show you a little bit what it looks like after the break. But that's the best way to avoid a merge conflict. Sometimes merge conflicts are unavoidable. when you are updating GitLab or GitHub, sorry, is maybe you and your colleague need to work on two different features that are in the same file. So merge conflicts aren't always bad. And usually it is up to your project manager when you're both updating and ready to go to production. So your project manager will combine all the changes and move them to production. So sometimes they are unavoidable and sometimes they are completely acceptable, but pull often and don't work on the production branch. I don't know what the best way to take questions is. Brittny, do we have any questions?
Hey, can you hear me? Yes, there's a couple questions in the chat. I'll start with a couple. What's one thing you wish someone had told you before you started using Git?
That's a really good question. I think I wish most that someone had told me it's okay to make mistakes and that you will make mistakes. Like, right, I think the number of times we've resolved merge requests, merge conflicts, it's okay, it's version controlled. So I wish someone had kind of told me that so that I would be more confident in like playing around and doing stuff, because you do have a complete history of the file. So there's not that much you can really screw up. You can undo most things. So yeah, experiment, play with it more. Is there any other questions, Britt?
Yeah, do you want to do a couple now and then or later?
Yeah.
Sorry to interrupt. Brittny, you're quite faint. I don't know if everyone else is, I think, having the same issue, but I don't know if you could speak up a bit, Brittny, or there's something with your microphone.
Is this better? Hello?
Not that much, no. We
Okay.
can hear you, it's just very faint.
I'll check my mic after this.
But it's fine, just go ahead for now.
Okay. I'll ask one more question and then, yeah, do you want to do them to save a little bit more time for later? So the next question is, our Git group ran a Git Nightmares event for Halloween where people shared mistakes they've made using Git and how they solved them to share learning. Do you have any Git nightmares to share?
Yeah. So I started using Git in school, and no one teaches you how to use it in school. They just, your first software engineering class, they just go, it has to be on GitHub. So I kept having these horrible merge conflicts because I did not understand how to branch. And so every time I went to go push an update to our group's repository for this group work, there had to be like a full refactor of the code because I messed it up so badly every time. To this day, I'm still not sure how I managed to do that. But thankfully, we actually had somebody who knew what they were doing, so could handle all the merge conflicts I continuously created. So I was very lucky, and yeah, it also just goes to show that you can get over most things in Git and GitHub. Like someone completely clueless, kind of ruining your project. So yeah, that was the big nightmare I've had. We've definitely also dealt with the, oh no, we put up something that we shouldn't have, which now that I know more about GitHub and I use it every day, less of a concern, but there is always that moment of like when you wake up from a bad dream, still kind of panicked. So there's always that a little bit. And we'll take one last question, Britt.
So I have a question here. I currently use Mercurial and Tortoise HG repository to version control our Fortin-based StatLab code modules. Is there an easy way to transfer this to GitHub?
Sometimes you can do what's called mirroring a project. So I've never used Mercurial or Tortoise, but they may be compatible with the mirroring function on GitHub. So I would look that up and see if that would be a good way to do that. If not, there are ways of putting existing code on GitHub, but by doing that kind of like quick and dirty method, you would lose all your versioning history. So I would look at either mirroring or possibly importing. I don't know if the import would work though. So I'm sorry, I wish I could give you a better answer. Okay, so this went a little bit faster than I thought it would. So we can take a 10-minute break. All right, hi again, everyone. Hopefully everybody had a good break. Hannah, if you want to open the poll, just so we get a sense of how many people have a GitHub account. And for those attending who have a GitHub account, if you don't mind letting us know in the poll so that we can get a sense of how many of you there are, that would be absolutely fantastic. In the meantime, I am going to drop a link in the chat to a GitHub repository that if you want to click along as I go through this, you are absolutely more than welcome to. And I'm sure you're going to see my entire team. Oh, it worked, finally. Hannah or Allison, is there a way that I could get into the chat for Teams on this meeting?
Yes, I'll activate it now. 1 second.
Thanks.
Should be open now, Tabitha.
See if I can click in.
1 sec.
I don't know why it's telling me. Oh, there we go. Perfect. So there's a link to a GitHub repository in the chat. That's where we're going to be working out of. Ooh, snap that over. When you go to it, it should look like this. If you don't have a GitHub account, we'll give the poll a couple more seconds. You can still visit this page and see what it looks like. You just won't really be able to click on much. You might be able to see this button here that says code. But if we could get a, like, Hannah, if you don't mind sharing the poll.
Yes, no problem. Let me start sharing.
All right, that is super exciting. Love that we have like so many people that answered using GitHub. For those of you who aren't, we totally understand. But do feel free to engage in the Slido and ask a lot of questions. We'll do our best to answer as many as we can towards the end, or maybe I'll get tired and we'll answer them in a few minutes. Thank you so much. And I'm going to go back to our demo. So if you don't have GitHub, I encourage you to at least go in and try it after the session. If you haven't already used it, even if your agency has a GitLab server, it's super helpful to have a sandbox to play around in or to kind of practice maybe with some of your colleagues on this meeting from other organizations. So usually we go through a very quick demo of what a GitHub or a GitLab project or repository looks like. In GitHub, they're called repositories. It has, the username of who owns the repository, has the name of the repository, and it tells you if it's public or private, so the level of access that people have to it. So I've made this one public so that you can all see it. If it were private, I would have to manually add you, or you would all have to request to be able to see it, and we don't want to deal with that. So also, I have nothing to hide on this because it's just a sandbox one, so we might as well have it open. So we get our little bit of information. So we have an about me. This is, I wrote this when created the project. It says that I have one person watching, that would be me. And then we have what are called 0 forks. So I mentioned forks in the first half of this. If you're not familiar with a fork, what it is that it creates kind of a parent-child relationship between a repository and essentially its copy. So if you fork this repository, you would be making a copy to your account on GitHub, but you would still have a link. So you could request to merge changes from your version of it into the parent version, which would be the one you forked from me. And you can also pull any updates that say I made as the parent repository. Sorry, the cat is upset again. So to fork it, it's really easy to do. It's just this little button here. Unfortunately, I can't fork it because I own it, which is kind of annoying. But if you are following along and you want to click along, please feel free to hit that fork button. You will get, the opportunity to either change the name of the project. You don't have to have the same name as somebody who's forking it. You can also change the level of access, so you can make it private once you're forking it. And you can change the description if you want as well. So please absolutely feel free to take this. If you're wondering about when would be a good time to fork a project, it's usually when there's a project or a set of code that is almost like a template for something that you want to do. In that case, you might want to actually keep that parent-child relationship so that if there are updates to that template, you can get them very easily. It also helps give credit to where you're getting your code from. So, if I am using someone's code as the kind of the fundamental base for my project, I probably want to fork it to make sure that they get the credit for it and that they know, oh, hey, my code is being used by someone else. So that's kind of the forking side of things. I know there were some questions about that on the registration. Other questions that we noticed were about the actual version controlling itself. So when we look at the main view of our repository, we see this line here of, my account, and then this weird message. This is what's called a commit. And a commit is like a save point. So you can save your document like as much as you want in Git, but you can also create these very specific save points. So if you're really happy with where something's at, you can create a save point to then get ready to put into production. Now, save points commits in Git and GitHub have a little bit more information than, say, if you were just saving a document, on Windows. So you can actually click on this weird sentence or half sentence. And you'll get some additional information. So with the commit, we have what's called a commit message. When we go to do commit messages, one of the things that I learned was the best practice is to finish the sentence, this commit is to blank. You want a commit message to tell you what it's doing without being too long. Because when you do have a large project, you'll have a lot of different commits, and you may need to go into the history of a project. It's totally reasonable to. I do it all the time, but you need to be able to find things very quickly. And when you have other people reviewing your code, they need to also know what you're doing and why you've done it. So in this commit, I said, okay, I just added this edit status to this file. If your commit involves multiple files, because maybe you're writing a feature that spans multiple files, you may not have this part, so you may not have the file name in it, but you should say what the commit is for and if it's resolving any particular issue or problem. We get the time that the commit was made, and then we also get this insanely long string, and this is the commit ID. If you want, using git bash or using like GitHub for desktop or something, you can actually search by commit. So if something happens and you need to revisit it, or you need to change the commit because maybe something went up that shouldn't have, you can actually go into the commit by its ID number. And then we see actually what the details are of the commit. So, and this is another part where it kind of deviates from where you normally save a file. So when you normally save a file, you just see that you saved a file. In Git and GitHub, depending on the file, you can actually see line by line what's changed. So when we see this green, it means that we've added something. We also have the ability to leave a comment. So if I'm working with somebody else, they can comment on this and ask questions about it or propose revisions. So whatever you would comment on a thing, from a project management perspective, it makes it really easy to use. You can see someone's already commented on it. So, but yeah, from project management perspective, it means that you can keep conversations right with what it is you're commenting on, rather than losing emails, which I'm really good at. So I tend to use a lot of GitLab things. We use GitLab at StatCan, so we use the comment features a lot, all over the place there. And because this is a public one, anybody can comment. So this would be a place where if you had a large machine learning project and something wasn't clear or something wasn't commented in your code, people could ask questions about. And before we get into the actual doing of things, there is one last thing or two last things that we need to talk about. One is issues. So along this top bar, you see that there's code, there's issues, there's pull requests, there's all these things. We're going to go to issues. Issues are a super important project management feature on GitHub. They can be really useful, especially in machine learning context, for when something needs to be fixed, when a new feature needs to be added, if you're switching models. So I'll get you to click along with me on your forks. So I can see that 53 people have forked this. So if you want to go ahead and click the lovely green button of new issue, you will get taken to the screen. So your issues all have to have a title. So you have to say kind of very briefly what the issue is. So let's say I'm going to add a cat description. If I have more detail, I can add more detail. So for those of you clicking along, you don't have to make the same issue. You can make whatever issue you like. I just have a cat roaming around trying to destroy my life, so it's very present at all times. Now, issues do support Markdown. So if you wanted to, you could spec it. Add fun things like so if we go to preview, you'll see that the Markdown renders and our asterisks turn into regular bullets. Then we can do things like assign them. So if you're working on a project with multiple people, you know, and you have somebody who is your data engineer, and it's a data engineering problem, you can assign it to them. You can also assign it to yourself. You'll get an email or a flag that says you've assigned an issue. For the project management kind of thing, there are labels. So we can say it's for documentation. We can add more labels. So if you want to create milestones or labels for specific features, you can do that. And then this issue will be linked to those labels so you can see how everything's going.
Can I interrupt you for a quick second?
Yeah.
I have some messages in the chat or in the Slido to say that they can't. Some folks can't see issues in their fork, only in your version. That weird.
It might be because the person is person already forked and they are watching their own repository, because that happened to me too. So yeah.
Thank you.
I can see it.
That's a relief. I was like, I don't know how to fix that. So thank you. Yeah, so make sure you're in the right place. If you have project milestones, you can create them, add them in here. And then when you're ready, you can hit the green button. All major actions in GitHub have a green button. In GitLab, it's a blue button, but it highlights that this is a major action that you can take. So I'm going to submit my issue. And we can see that it has a hashtag number 16. We have some issues coming in. That's great. From all over. So that's fantastic for when you're managing a project. However, issues can't exist on their own. You have to resolve them in some way. So if you go to your code, so I'm just going to click on my code button here. It's going to freak out and load. We talked a little bit about branching. So we talked a little bit about having a self-contained development copy of your project or your repository that you can work on and play around with, and then a production copy. So using GitHub terminology, what this looks like is the main branch is what's called a protected branch. So it's the production branch. Now I can make changes to my own production branch. just like you can make changes to your own production branch. But that's not generally a great idea. This is how you end up with merge conflicts. And then you have to do what's called a refactor of code, or you have to resolve the merge conflict, and it can be a huge pain. So instead we use branches. So when you have this main branch, you can click on it and it says switch between branch and chat tags. We just have one, that's the default. I'm going to create a new branch. Make sure you're on your project and you can create a new branch on yours as well. So I'm going to create a test branch. And it tells me, what am I creating? I'm creating a test branch, and that it's going to take our main branch and copy it. So if I had multiple branches, I could pick which branch to copy from. So if I'm working on a feature with my colleague, I may want to copy their branch to make sure that I have their changes. It lets you know that it's worked because we get a blue bar of success up here. So we know that our branch is created, and it automatically takes us to our new test branch. Sorry, I'm cat trying to walk on a keyboard, and he likes to hang up on calls. Oh. It's also not the most graceful animal. So the first thing we are told is that our branch is up to date with our main branch. So both branches have the exact same information. That's great in that we don't have any merge conflicts, not great in that we haven't made any changes. So this is the quick and easy way to make a change to a file in the browser. Not my favorite thing to do, but when our infrastructure goes down, it's actually really helpful. Or if I need to make a change to documentation really quickly and I'm on a personal device, or I don't have an IDE on my device, I can do it this way. So I am going to make a change to test.txt. So I'm going to click on it. It says, okay, we've only ever had one contributor. It tells us when the last time we changed it was, and shows us what is in the file itself. I'm going to click on this little pencil guy here that says edit the file. There is also a couple other options. So you can open it in GitHub Desktop. I don't have GitHub Desktop, so it's just going to take me to a download page for it. Or the GitHub Dev, that's kind of like an IDE. But to make life easy, I'm just going to edit the file with the regular edit. Now, according to my issue, I said that I was going to add the height and weight of the little demon that is apparently cat. So feel free to enter in whatever changes you want. They can be related to the issue you made. They don't have to be. The point is just that you get some practice. Now, this is a text file and not a markdown file, so I don't really have to worry about formatting too much. It's not going to render very pretty or anything. I have no idea how tall a cat is, but he is a long boy. And he is a heavy boy because I went away and a friend of mine got real excited about feeding him. So he is a chunky boy at 13.5 pounds. He's on a diet. So when you're happy with your changes, you can scroll down and make a commit. Now, I talked a little bit about the commit messages, letting us know, like, let people know what it is you've changed. So answering the question, this commit is to that information. And you have two options here. So we can commit directly to the test branch, which is great if you think you have a bunch of other changes that you want to make. Or we can create a new branch. We don't want to do that. And it'll start what's called a pull request, and we'll get into pull requests in a second, but the default one that commits directly to the test branch, that's the one that you want to make sure is selected for this demo. If we did this on our main branch, our production branch, we would absolutely be clicking this one because we don't want to commit or push to our main branch. So if you are working on the main one, just click here and you can create a new branch. But I'm happy on my test branch, so I'm going to hit the green button to commit my changes. We can see that, great, our commit has worked. If I go back to the main view, I'm on my test branch, and where we said that we saw that both branches were at the same place, now we see that we are what's called one commit ahead. So we've made one save point past where our production branch was. And right away it says, do you want to compare and pull request? A pull request is when you want to copy your changes over to your production branch. In GitLab, they are called merge requests. In GitHub, they are called pull requests because the main branch is going to pull the changes. So because it has already given me this option, I'm actually just going to be lazy and hit this button here. You can also access it from the top where it says pull requests. So if you did make a bunch of changes or you're waiting on changes, you may want to go here and do it, but might as well do it where it's easiest. Ooh. So it says we can open a pull request. This isn't going to do the actual merge from our test to our main right away. This is to create a request to do it, almost like an issue. So it gives us the information of, this is super important and I always mess this up. The base is where we want to copy our changes to. And the test is what is being copied. So if you are working with a bunch of different branches, make sure you have the right stuff selected. GitHub has done this check for us that says able to merge. So it's made sure, okay, we're not going to have any conflicts. Everything will copy over. It's fine. As a default for the title of the pull request, it's taken our commit. That's fine. That doesn't bother me. I can leave that. If you want it titled something else, you're absolutely able to. In the the description area is where things get fun. So this is where you can add more information. So we can say, we can actually link it to the issues that we made. So I can say this closes, mine's number 16. If you use the hashtag, you'll be able to see all the issues. So I'm going to do 16, add cat description. So that now this is tagged to the issue that it's related to. There is a way to actually create this as like a keyword. I don't know why it's not working, but when we're happy with what our description is, we can create the pull request. If we're on a project where maybe we don't have the permissions to make changes to our production branch, our main branch, or maybe we want someone to check out what we're doing, take a look at it, we can add a reviewer. So I can ask someone to take a look at this. I can assign it to somebody. So that person has to actually do the merge itself. And then I can make our labels. So we had our labels before so that we know what this is related to. I'm going to add our documentation label again. And if we had any milestones, we would relate it to our milestone. And when we scroll down, we see that there's one commit that's going to be on our pull request. We created one save point. We had one file changed, and there was only one person involved. So hit that green button when you're ready. So what GitHub just did is that it did a double check to make sure that we can actually merge it. It checked before, it checked again. If you have pipelines, so if you're using CI, like you're building a GitHub website, or yours is set up to run a model, which would be cool, this is where it does that test to see if the build works. If the build fails, it's going to let you know here. So we can do some rules. It's saying we looked, there's that continuous integration, those pipelines haven't been added, which is fine. We don't want to hit close pull request for this. When you close a pull request without merging it, it's kind of like saying, it's kind of like throwing it out. So if it wasn't super relevant and someone had made a pull request to the project, I would just close it out and I wouldn't merge it. So I'm going to merge this pull request. So I'm going to hit the green button. And it's going to ask me to confirm because we're going to production. And now what happens is that I can actually delete this test branch. So I don't need the branch anymore. So I'm going to just delete it. Saying I can bring it back if I want to.
Hey Tab, can I take this
Yeah.
moment to, I see some confusion in the Q&A and I just wanted to confirm. If someone was to try to make a branch off of this, would they be able to, because this is from your namespace, or would they have to fork it and then make that branch from theirs? Okay.
Yes. Yeah.
So if you're unable to make a branch, it's because you're in Tab's namespace, and what you need to do is fork it and then go to your namespace. So it'll be your username / coffee code demo, and then you'll be able to make a branch from there. Thanks.
Thanks, Britt. And if you want to know how to get to any of your projects, in the very top right, it's really tiny. There's this little icon, mine's green and white. Just click on it. That's kind of your basic navigation. You want to go to your repositories. So if I click here, I only have the one under this account. This isn't the account I usually use, but this will be where your version of the copy and code demo was forked to. So my apologies for the confusion. Hopefully it's able to work. So yeah, branches. So we deleted our test branch because we don't need it anymore. Usually when you create a branch is based on a feature. Depending on your project, you may use branches in different ways. So some people use it, excuse me. Some people have their production branches labeled to indicate releases. So you'll see like, version 1.5, 1.6, but generally when you're working on those development branches, they are based on a particular feature. So you generally don't have one that's like, this is the Brittny branch, this is the Tab branch, just because things can kind of get messy. Because then you always are having to take all the changes from that main branch and merge them into your named branch. So I would have to merge them always into the Tab branch. And there's always conflicts when you do that, particularly if your changes aren't always accepted by your project lead. So I always just branch off of the main or the master. This is considered to be best practice when you're doing a new feature. if you are working with someone on a feature, like I said before, you may want to branch from their feature so that you have the correct kind of source of truth. Okay, so that was pretty much of what I had. Hoping to get Britt, if we have time for questions. I think we do.
Yeah, I have a whole bundle. Are you excited?
I'm so excited.
So I'm gonna mishmash a bunch of them because there's some consistent, like there's some patterns I see. So can we go over the vocabulary of like a fork, a branch, commit, and clone?
Sure. So a fork is when you're copying a project from somebody else's namespace in GitHub to your namespace, and you're going to have a parent-child relationship with their project. A branch is when you're creating a copy of the code within the project itself. So when I create that test branch, only I can see it, or only this project can see it. When you're cloning, you're just creating a copy that has no relationship to GitHub. So we're just creating a copy onto our desktop. So hopefully that clears it up. So most of you could go and clone this. You wouldn't be able to make any changes to it though. So it's just a fancy way of downloading a project and making sure that you're getting all the Git history with it, but you don't have any kind of relationship to the original project on GitHub. So hopefully that makes sense. I will take more questions, Britt.
Yeah, I'll keep them coming. My next question here is Git worth using for individual or one-off projects as well as long-term projects with multiple contributors?
I find it's worth using for one-off projects. I can't tell you how many times I've been saved by past me putting a one-off project that only I worked on GitHub because I often need that code again. And I have either moved jobs or have lost the original files, from a hard drive corruption, and the project is on GitHub and I can go and refer to it and use that code again. So there is a dashboard that I essentially have used as a template for 5 years now.
I can second that personally for my own things too. We have another question here that is asking, I guess the question here is, there seems to be a preference for GitHub versus GitLab in the presentation, but maybe we could take this as an opportunity to discuss the difference.
Yeah, so I just use GitHub for the presentation because it's easy to access for everybody. At StackN, we use GitLab. Lots of places use GitLab. It's a little bit more enterprise geared. Mentioned before in the first part of the presentation that continuous integration and development, those pipelines that do things for you, those are all built into GitLab. You don't really have to think about it. You can just do it. With GitHub, there are a number of different services, so GitHub supports it as well, but you have to pick and almost install which one you want to use. So that's the big difference, is on that CI side.
And in addition to that, there was a question that was asking if you try to use your GitLab to get into GitHub. Yeah, those are different. So it would be like using your Hotmail account or password to get into your Google.
Yeah.
Just to quickly go over that. Can you point to any good best practice examples of public GitHub or GitLab repositories for statistics or machine learning projects?
Do we have any for machine learning projects? There is a StackN GitHub. So you can have organizations on GitHub, like groups. I think there are a couple on StackN. I don't know specifically. There is, the UN has a bunch of their stuff on GitHub. Once again, I don't know if it's specifically for machine learning though. Sorry, been out of the machine learning game a little bit.
We have a question here of how would I set up a repository to play around with?
That is super fun. We can click and do that together. We have like 2 minutes. So when you click down on this little circle and arrow boy here and go to your repositories, there's this green button that says new. Give that a click. So you just enter the name, you can enter the description, set your privacy level. I like to add a README file because it always guarantees you have documentation, which is another really important best practice. Talked a little bit about the git ignore right before the break. So these are the 2 files that you usually create at the start of the project, is the README, the documentation, and the git ignore, which tells Git to not put up confidential things. So if you can create it at the beginning, absolutely do it. And then licensing. So if you have a general license that you want to use or that your project falls under, you can select it here and it will generate that documentation for you. And I think we have time for one last question.
Yeah, I asked you this one. Could you give examples of kinds of projects you've used GitLab or GitHub or GitHub, GitLab at StackCan? You have corporate license. How prevalent do you think the use of Git, GitLab, Git is at StackCan? Statistics Canada.
So the amount of GitLab projects on Statistics Canada is always increasing. That is a data set that I have to rerun today. So we use it quite a lot. We used it GitHub a lot over COVID so there are groups that had to create dashboards and other statistics to report on vaccination rates or rates of spread. So those are all on GitHub. So we use them a lot for that. And then we have used projects on GitHub for OpenSDG to create a global indicator framework hub. And there are a lot of different countries that used code from the UN, forked it, and were able to create their own hubs from that. I use it internally at StackCan to create dashboards and to work with my colleagues. So we do Git training at StackCan. All of our Git training is hosted on GitLab. So Brittny's made contributions to it. Our other colleagues have made contributions to it, so it's been super useful. And I think with that, we're out of time because I know that we want to close things up. But if we want to get the last poll question up to just really quickly kind of revisit that same question that we saw at the beginning. So having gone through this now, what do you think of when you think of Git or GitHub? So hopefully it's not as intimidating. And if I can get someone to share the Slido, that would be super helpful. I mean, I love that I'm seeing useful now. Like, big fan of that. It seems like things are a little bit more positive. So that's great to see. There are lots of Git and GitHub resources. So, and there are lots and lots of Stack Exchange posts. So we'll leave this open for another minute, and then because I've gone over time, I'll turn it back to Allison and Hannah, sorry. But yeah, so hopefully this was enjoyable for all of you. We can try and write up an FAQ based on some of the questions that we didn't get to today. and share that. But thank you all so much. Hopefully you got a bit of a sense of what GitHub is and how you can start to use it in machine learning. But I will turn it over to Allison and Hannah. So thank you all so much.
Well, thank you, Tabitha, for such an excellent, really clear journey through the first steps of Git and GitHub. I think that's just really excellent introduction, and great to see all those comments there showing how useful people have found that. And thanks to Brittny as well for moderating the questions, and to Hannah as well for moderating for the technical setup. Just a quick few minutes just to close the session, just to let you know that we will be sending around a feedback survey for everyone to fill out. Be grateful if you could spend a few minutes on that to let us know how you found today's session. And also we will be posting the recording and slides from this presentation shortly on the ML group website. So please do go and take a look at that website. There's lots of recordings from our previous coffee and coding sessions, also information about all our activities and different presentations, use cases, research projects that we've been working on. And just finally as well, a quick plug for our annual webinar that's coming up at the end of this month. We are going to be bringing together all the highlights of the work that the machine learning group has been working on over this past year, looking at applications of machine learning, including web scraping data, text classification, imagery data, and AIS shipping data, and also looking at statistical production issues when trying to integrate machine learning into our statistical systems. So quality of training data, model retraining, and IT infrastructure. It should be a really stimulating and interesting session. So you can sign up on the Eventbrite page, and we'll send around details of that afterwards to you as well. So yeah, thanks again to Tabitha, Brittny, and the team at Statistics Canada. Thanks for today's great session. Thanks to you all for joining, and we'll hopefully see you at the webinar or another event sometime soon. Thanks very much, everyone, and have a good rest of your day.